This is Professor Pelton. This is Trigonometry Chapter 4, Section 1, Verifying Trigonometric Identities. This is Part 1 of 2. So in Section 1 we're going to use the identities that we previously learned in the prior chapters. We will learn new identities in the upcoming sections. So the reciprocal, quotient, Pythagorean, and even odd identities are given here. We'll use these to verify the following identities. So the goal here is to get either the left or the right side to match by swapping things around. So there's a variety of ways to do it. There's not one way to do any one of these. So first I'm going to take the secant. I want to make a cosine out of that. Use the reciprocal identity. So that's 1 over cosine. And cotangent is a ratio identity, which is cosine over sine. And the cosines will cancel, leaving me 1 over sine, which is cosecant. And using the reciprocal identity, 1 over sine is cosecant. So we have verified this is actually a true identity. Pause the video, try the student problem. Okay, for the student problem, I'm going to swap out cosecant 1 over sine for the reciprocal identity. I'm going to swap out tangent for the ratio identity, or the quotient identity actually, sine over cosine. Okay, it's a bad x, make a better x than that. Okay, the sines cancel, leaving me with 1 over cosine. And the reciprocal of 1 over cosine is secant. And we proved it. All right, let's go to the next page. Okay, so we know in this one we have 2 terms and being compared to 1 term. So as a result, we need to add these together. So we should probably make fractions first. Since these are not like terms, we can't add this one with this one. So if I swap out tangent with its ratio, or quotient identity, which is sine over cosine, and we'll just put a 1 over the cosine. Okay. So we notice here is we're going to get sine squared of x over cosine plus cosine of x over 1 equals secant. Okay, so in order to add these, we need common denominators. The common denominator of 1 in cosine is cosine. So this one stays the same since it already has a cosine denominator. And this one needs to be multiplied by cosine over cosine to make a common denominator. So the result is sine squared of x over cosine plus cosine squared of x over cosine equals secant. So now we have common denominators. We can add the fractions together and get sine squared of x plus cosine squared of x over cosine of x equals secant. And using the Pythagorean identity says that cosine squared plus sine squared is 1, or sine squared plus cosine squared is 1. So I get 1 over cosine equals secant. And using the reciprocal identity, secant equals secant. So we proved it. Alright, pause the video, try the student problem. Okay, so again here we have 2 terms. We need to get it down to 1 term, so we need to add these together, but they're not like terms. So we can't add them, so we need to make fractions. So we have cosine of x times sine of x over cosine of x when we swap out cotangent for its ratio. And sine of x over 1, we'll make that a fraction. Okay, so we need to make common denominators. The common denominator of cosine and 1 is cosine, so we're going to have cosine times sine. Oh, that's a mistake, sorry. And that is the wrong ratio. The ratio of cotangent is cosine over sine. So the common denominator is sine. So we're going to get cosine squared over sine. And the sine of x over 1 needs to be multiplied by sine over sine to get the common denominator. Okay, now that we've used our ratio of 1 to get the common denominator, I'm going to have cosine squared of x over sine plus sine squared of x over sine equals cosecant. So now we can add the numerator since the denominators are the same. So we have cosine squared of x plus sine squared of x over sine equals cosecant. And again, we're using the Pythagorean identity. The cosine squared plus sine squared is 1, or sine squared plus cosine squared is 1. Either way, I get 1 over sine equals cosecant of x. And using the reciprocal identity, cosecant of x equals cosecant of x. And we've proved it. Okay, let's try the next page. Okay, so here again we have two terms and we need to get down to one term. So I have 1 here, we have 2 on the left. But I notice I have a cosine in common, so I can swap out a cosine, or factor out, or divide out, however you want to say it, which leaves me with 1 minus sine squared equals my cosine cubed, right? Because if I distributed it back, I would get what I have up top, which I don't want to do. Because what I notice is if I use the sine squared of x plus cosine squared of x equals 1, which is the Pythagorean identity, if I subtract sine squared from both sides, cosine squared of x equals 1 minus sine squared of x, which happens to be what I have in my problem here. So that'll give me cosine of x times cosine squared of x equals cosine to the third power of x, or cubed, when I do the swap using the Pythagorean identity. So that gives me, since that's the 1, cosine cubed of x equals cosine cubed of x, and we've proved it. All right, pause the video, try the student problem. Okay, student problem. Again, we're trying to get it down to one term. When I notice I have a sign in common, so if I divide out a sign or factor out a sign, I get 1 minus cosine squared. And what I notice about the 1 minus cosine is, again, using the Pythagorean identity. If I subtract the cosine, sine squared of x equals 1 minus cosine squared of x, which is what I have in my problem. So I'm left with sine of x times sine squared of x equals sine cubed of x. So sine cubed of x, since that's a 1, equals sine cubed of x. So we proved it. Okay, let's try the next page. Okay, so I notice here is I have one thing on this side, but I have two things on this side. So I either have to bring the right side, add them together, or I have to break apart the left side. So either one will be a sufficient strategy. Since we've been combining things earlier on, we'll break things apart this time to kind of mix it up. So if I break this up into two fractions, right, because if I take a fraction, 2 plus 3 over 5, that's 2/5 plus 3/5, right? So I'll do the same thing here with trig. So that's 1 over cosine plus sine over cosine equals secant of theta plus tangent of theta. And when I notice using my reciprocal identity, 1 over cosine is secant. And sine over cosine is the tangent ratio, or quotient identity. So that's tangent of theta. Okay, what you notice in this problem, I swapped to tangent at this point I swapped to theta at this point because truly we don't use x in trig. It's angles, not side lengths. Okay, try the next student problem. Pause the video. Okay, strategy for this one again is to make one term into two terms. So we'll split the fraction. 1 over sine plus cosine over sine equals cosecant of theta plus cotangent of theta. So using the reciprocal identity, 1 over sine is cosecant. And using the quotient identity, that's plus. Cosine over sine is cotangent of theta. So we have proved it. Okay, and that is the end of part 1.